So we're going to finish up biostatistics with the concept of non-parametric statistics. So the idea of non-parametric statistics is for all of the statistics we have looked at, confidence intervals, hypothesis testing, 1 sample, 2 sample, 3 or more samples. In all those cases, including regression, there were assumptions that were made. Either the assumptions were about the distribution, that the population needed to be normally distributed, or at least approximately normally distributed, or we could use the central limit theorem if we were comparing means, and because the central limit theorem says as long as n is greater than 30, that the sample means are approximately normally distributed. The sampling distribution of sample means is approximately normally distributed. But sometimes we have cases that we do not know that these assumptions hold, and in that case we're dealing with non-parametric statistics. So this lecture is on 13.1, which is just the basics, an overview of what non-parametric statistics are. Parametric statistics, it does require assumptions about the nature and the shape of the data involved. Often is that the data needs to be normally distributed. With and we are testing parameters such as comparing means, or comparing population standard deviations, or drawing inferences about population proportions. In non-parametric tests, we do not use parameters like the population mean, or the population standard deviation, or the population proportion, and they do not require normality to be assumed. Now, the advantages are that they can be applied to many situations and does not require normality. It can be applied to also to categorical, also known as qualitative data. Sometimes these computations are much simpler, making it easier to understand and apply, and often the effect of outliers is less than they are in the parametric tests. Though are that it tends to waste information. Often we don't use the actual numbers, we're using the ranking of how the numbers rank. It's not as efficient as parametric tests, so if you know that the data does meet the assumptions for a parametric test, the parametric test is better. We also often need larger sample sizes in order to reject the null hypothesis. And if the outliers are important, non-parametric tests often do not take them into consideration. Now, if we're looking at one sample test, the parametric tests that we studied this term were the one sample z-test, the one sample proportion test, the one sample t-test. The non-parametric tests that we're going to briefly look at are the sign test. In Minitab, it's called the one sample sign test. The Wilcoxon signed rank test. In Minitab, that's called the one sample Wilcoxon test. In matched pairs, in parametric, we did paired t-tests. In non-parametric tests, we'll do the sign test, and it'll still be the one sample sign test. And the Wilcoxon signed rank test, we'll do Minitab the one sample Wilcoxon test. Independent samples, we had the two sample t-test, and then we also talked about the two sample z-test, but remember we said it's almost never used, and Minitab didn't even do a two sample z-test, so we didn't really do one, but I did mention to you in chapter 9 that it was a possibility. Now, in non-parametric tests, to compare two independent samples, we're going to look at the Wilcoxon rank sum test. Minitab does not do this test, but it does an equivalent test known as the Mann-Whitney test. Minitab does do the Mann-Whitney test. If we have 3 or more independent samples that we're trying to compare, and if we're doing a parametric test, recall from chapter 12, we called that test an ANOVA test, analysis of variance. In non-parametric test, we're going to do what's known as the Kruskal-Wallis test. Minitab is it's called Kruskal-Wallis. Correlation, there's a parametric test known as linear correlation. We saw that when we did the Pearson product moment correlation coefficient when we were looking in chapter 10. And in non-parametric tests, there's a rank correlation test. I'm not going to cover that at all in this class, but it is covered in the more advanced statistics. The lecture on the basics of non-parametric statistics. We're going to continue this lecture in the next lecture slide. So we'll move on to some specific non-parametric tests in the next lecture.